Section 7.2, Multiplying and Dividing Radical Expressions. On the product property for multiplying radical expressions, I have a to the nth degree and b to the nth degree are real numbers. Then a to the nth degree times b to the nth degree equals a times b to the nth degree. Notice, to be able to perform this operation or product, my indexes must be the same. Then I can just multiply the radicands together under the same index. Let's look at an example. Here I have a square root of 8 times the square root of 6. Of course, our index is 2. We can do this in a couple of different ways. First, I can multiply these two together as the operation for the property states. That gives me the square root of 48. Then I can simplify to be the square root of 16 times 3. And I know the square root of 16 is 4. And I leave 3 under the radical. So I have 4 square roots of 3. I can also perform this operation by simplifying each first, and then multiplying. So that will give me the square root of 4 times 2 times the square root of 6. That gives me the square root of 2 under the radical, and the square root of 4 comes out. 2 square roots of 2 times the square root of 6. But I can now multiply. It gives me 2 outside the radical times a number 1 that is outside the radical, which gives me 2 square roots of 12. Then I can simplify that to be 2 square roots of 4 times 3. The square root of 4 is 2. 2 times 2 is 4 square roots of 3. Notice my solution is the same. It may have taken a couple more steps on this procedure, but this procedure might be well used when my numbers are quite large. On this example, I want to multiply and simplify. Assume all variables are positive. Here I have the cube root of 20 times the cube root of 16. So I have like indexes, so I'm going to multiply the radicands together and put them under the same value of index. So that's the cube root of 20 times 16 is going to give me 320. And I know that if I can split this up into a perfect cube root, it's going to be the cube root of 64 times 5. Then I can perform the operation. The cube root of 64 is going to be 4 cube roots of 5. In this case, it might be easier to simplify each first, then perform the product. On my next example, I look through my products and I realize that my indexes are all 3. Therefore, I can multiply the radicands together. I also want to multiply the coefficients of the terms out fronts together first. So 1 times a negative 2 is a negative 2, times 1 is a negative 2. And the product of the radicands go under the index of 3. 2 times 16 is 32, times 2 is 64. M cubed times m squared is m to the 5th, times m to the 6th is m to the 11th. Now I'm going to simplify in the interior. Gives me a negative 2 cube roots of 64. And remember, I need to have my exponent divisible by my index. The closest one to 11 would be 9, so that would be m to the 9th times m squared, which the product of that is m to the 11th. Now let's simplify inside. That's going to give me the cube root of 64 is 4. 4 times a negative 2 is a negative 8. M to the 9th is m cubed. When I take the cube root of that, and what's left on the interior is m squared. So my solution is a negative 8m cubed to the cube root of m to the 2nd. Again, on this example, I want to multiply and simplify, assume all variables are positive. I have 2 radicals to the 4th root. Therefore, I can find the product of those 2 radicals. What I need to determine is whether I want to simplify each first, then multiply, or multiply them together. Since I don't have the 4th root of 3 or the 4th root of 27, I want to multiply them together to see if I can get a 4th root of a number and simplify. So I'm going to multiply these two together first. -2 times 1 is a -2. The outside multiplies the outside, the inside multiplies the inside. And I have the fourth root. 3 times 27 is 81. A squared times a to the 7th is a to the 9th. B to the 8th times b to the 2nd is b to the 10th. C to the 5th times c to the 1st is c to the 6th. Now I can simplify, and I know that I do have a fourth root of 81. It is 3, but I'll leave that in the radical until I simplify my variables. So I have a -2. The fourth root of 81. A to the 8th times a. B to the 8th times b squared. And c to the 4th times c squared. Now let's simplify this expression. So I can take the fourth root of 81. That would be 3. 3 times a -2 is a -6. The fourth root of a to the 8th is a squared. The fourth root of b to the 8th is b squared. And the fourth root of c to the 4th is c. Then what's left under the radical is what I could not take out, which would be a, b squared, c squared. On this example, I want to multiply and simplify and then assume all variables are positive. Here I am multiplying two radicals together. I can do that because I know their indexes are the same. It's 2. Since I know that I can take the square root of 72 when I simplify it, I'm going to simplify each of these separately, then find the product, and then simplify again. So let's start with this radical. Here I'm going to have the square root of 6. And I can break x cubed into x squared times x. Y to the 5th can be broken into y to the 4th times y times z. The next radical, I have the square root of 72, which I know I can break into 36 times 2, x to the 6th, y to the 8th, times y, times z squared. And I don't have to do anything with my x to the 6th and z squared because I know I can take the square root of those. Let's continue. And I'm going to have on this radical, square root of x squared is x. The square root of y to the 4th is y squared. And what's left in the radical is 6xyz. Times, simplify this radical, square root of 36 is 6. Square root of x to the 6th is x cubed. The square root of y to the 8th is y to the 4th. The square root of z squared is z. What's left in the radical is 2y. Now we can find the product of those two radicals. Again, their indexes are still the same, so I can multiply. That's going to give me 6 times 1 is 6. X times x cubed is x to the 4th. Y squared times y to the 4th is y to the 6th. And z. And on the interior of the radical, 6 times 2 is 12. X. Y times y is y squared. Z. Now I can simplify again by taking the square root of the inside. We can do that by bringing down my 6, x to the 4th, y to the 6th, z, square root of 12 can be broken into 4 times 3, x, y squared, z. And our final simplification, square root of 4 is 2. 2 times 6 is 12. Square root of y squared is y, so I'm going to bring down my x to the 4th. Square root of y squared, I said, is y. Y times y to the 6th is y to the 7th. And I bring my z down. And what's left in the radical is 3xz. You also could have found the product first, and we would have ended up with the same solution. Here I have a monomial times a binomial, therefore I'm going to use the distributive property. I'm going to show you two ways to do this. First, we can just distribute, then simplify. So let's do that procedure. Negative 3 times 4 is a negative 12. And a negative 3 times a negative 1 is a positive 3. And then I have the square root of 8. So I have 3 square roots of 8. Now I need to simplify this because I can break up the square root of 8. That gives me a negative 12 plus 3 square roots of 4 times 2. Negative 12 plus square root of 4 is 2. 2 times 3 is 6 square roots of 2. And I cannot combine these two terms because they are not like terms. Another way to solve this problem. What I could do is simplify the expression first, then distribute. So I'm going to bring down my negative 3, 4, minus, and then I can break up my radical into 4 times 2. Bring down my negative 3, 4, minus, the square root of 4 is 2, times the square root of 2. Now I can distribute. Negative 3 times 4 is a negative 12. Negative times a negative is a positive. 3 times 2 is 6. Square roots of 2. And you can see I did end up with the same solution. Therefore, when solving a problem like this, it will be your choice on what way to proceed. On my next problem, again, I have a monomial times a binomial. I'm going to use the distributive property. Here I have the square root of 2 times 2. So I'm going to take the coefficient out front, 1 times 2, and get 2 square roots of 2. Plus, square root of 2 times the square root of 2 is the square root of 4. Now, I know that in my head, so I could have simplified that already, which would have given me 2 plus 2 square roots of 2. And I know that this is 2. Square root of 4 is 2. Again, on this problem, I want to multiply and simplify, and I want to assume all variables are positive. Here I have a monomial times a binomial, and I know I can use the distributive property. It's my choice whether I want to simplify the interior, then distribute, or do I want to distribute first? I think I'm going to distribute first. So what I'm going to do is find the product of the square root of 3 times the square root of 6. Since the indexes are the same, I can find the product of the radicands. The square root of 3 times the square root of 6 is the square root of 18. Bring down the plus sign, because a positive times a positive is a positive. The square root of 3 times the square root of 8 is going to be the square root of 24. Again, I can perform that operation because the indexes are the same. Now I need to simplify both. That's going to be the square root of 9 times 2 plus the square root of 4 times 6. The square root of 9 is 3. Leave me with square root of 2 plus square root of 4 is 2. Square roots of 6. Again, I cannot combine these terms because they're not like terms. The indexes are the same, but the radicands are not the same. We'll discuss later how we can combine terms if and only if the indexes and the radicands are exactly the same. Let's take a look at the next example. Here I have the square root of a square root. To simplify this, I want to perform the square root of the interior of my big radical. So I'm going to bring down this radical, which is here, and I want to bring down this radical if I need to simplify. But I don't need to break these up. I can already take the square root of the interior of this. The square root of 64, we know, is 8. The square root of x to the 8th, we know, is x to the 4th. And the square root of y to the 4th is y squared. And that is just taking the square root of that radical. And that solution goes inside the bigger radical. Now I take the square root of that again. So here I will simplify. 8 can break into 4 times 2. And I can leave these the way they are because I know the index will divide evenly into them. The square root of 4 is 2. Square root of x to the 4th is x squared. And the square root of y squared is y. And what's left in the radical is just 2. In this example, I have the square root of the cube root of 512x to the 6th. As in the previous example, I want to do the same thing. I want to perform the operation of the interior of my bigger radical, here the square root. So I'm going to bring down my square root, and I want to find the cube root of the interior. So the cube root of 512 is going to be 8, and the cube root of x to the 6th is x squared. That just performed this operation. Now I want to take the square root of that solution. So that gives me the square root of 4 times 2, x squared. Square root of 4 I know is 2. Square root of x squared is x. And what stays in the radical is just 2.